Hi, my name is Xingyu Song, and I'll be talking about open source Vizier for the AutoML Conference Systems Track 2022. This is joint work with Sagi Porel, Chansu Li, Greg Konchansky, and Daniel Golovin, all part of the Vizier team here at Google Brain. To start off, I'd like to first provide a brief background of the hyperparameter tuning efforts here at Google. Internally, Google Vizier first launched in 2017 and has since then optimized and been the distributed backbone of many of Google's research and product efforts. Monthly, it services thousands of Google employees and has so far tuned millions of user studies. Later on in 2020, Vizier was launched on Google Cloud, specifically its Vertex AI product, in order to provide the same tuning service for external customers and businesses. In order to provide a research community a standalone and customizable version of the service, we've released open source Vizier, which is a Python-based implementation of Google Vizier's infrastructure and API. One of the biggest design questions raised for our hyperparameter optimization service is, why did we create it as a service? To answer this question, we provide some very diverse and different examples of user workflows which need to be tuned, each with their own unique constraints. For example, a user may wish to tune the hyperparameters of a machine learning model, optimize a chemical or biological process, or maximize the tastiness of a cookie recipe. There are also many different workflow possibilities. For example, the evaluation latency can take seconds to weeks, and the evaluation budget can be tens to millions of trials. Evaluation can be sequential or synchronous, and failed evaluations may be retried or abandoned. Early stopping may also be used to avoid wasting resources. A service is the best designed in order to handle all of these possibilities. In a service, the user has the freedom of requesting trials, evaluating trials, and reporting results. Furthermore, a service can preserve data on prior usage to suggest potential improvements. Here at Google, this led to our recent OpFormer paper, which used the Vizier database over Google Earth studies. We further compare open source Vizier with other packages. There are three main types of packages. The first, which OSS Vizier is part of, are services. Services can host algorithms on a server and are both flexible and scalable. However, they may require additional engineering complexity. The second are frameworks, which execute the entire optimization loop. While a framework is convenient and allows full automation, it requires knowledge of the user's entire evaluation pipeline. Lastly are libraries, which implement black box optimization algorithms. While they offer the most freedom, they lack technical features such as resource management and error recovery, and thus lack scalability and are limited to a single machine. Examples of services are our very own OSS Vizier, but also Advisor and OpenBox. Examples of frameworks include Axe and HP Bandstir. Lastly, examples of libraries include BioTorch, HyperOpt, and EmuKit. We provide an organized comparison between the mentioned packages, and as we can see, OSS Vizier provides high flexibility in client languages, allows parallel trial evaluations, and contains multiple features. We will now discuss the OSS Vizier infrastructure. OSS Vizier's distributed communication are formatted as protocol buffers and sent through gRPC. The backend protobufs are independent from any single setting and allow inter-machine communication between any languages and platforms. The core server-client communication in OSS Vizier consists of the following steps. First, a client sends a suggest trials request to the server. The server then starts a Pythia policy to compute the next suggestion. To keep track of the progress, the server records the details in an operation protobuf. This client will repeatedly ping the server on the status of this operation and eventually receive the suggestion. All transactions and operations are stored in the server's database, which allows for recovery in the case of an error or shutdown. I will now talk about the API primitives using OSS Vizier. In OSS Vizier, we consider a study as the entire optimization run. A study spec is the configuration for the study and includes details such as the search space, algorithm, and noise level. The search space is formed from parameter specifications, and the objective can be specified by the metric specification. Each parameter spec can be either a double, integer, discrete, or categorical parameter. Furthermore, each parameter spec contains details on how it may be scaled and also whether it has conditional parameters. In order to abstract away the use of protocol buffers, the user only needs to write code with PyVizier, which is a Python-based wrapper for all protobuf objects. This allows RPC protobufs to be decoupled from user and algorithm code. It also allows using the same Python libraries across all Vizier services. Lastly, it provides more Pythonic data structures. I will now talk about the API on the user and client side. On the server side, the following is a standard creation of a server. On the client side, the following is the full workflow. I will explain each component separately. The first portion of the code is for setting up the study config containing the search space and algorithm to be used. The next portion is to create the actual client. This code can be reused across different machines to work on the same study, provided that different clients use different IDs. Lastly is a tuning loop, where from the server, the client obtains suggestions which will be used for trial evaluations and reporting results. I will now talk about the API for developing algorithms. The first design choice we made is to allow fault tolerance on algorithms. A fresh policy will use previous trials in order to recover the algorithm state in the case of previous preemption or failure. The second design choice is to allow the policy to selectively choose which trials it will use. This allows scalability for algorithms which work in batches or populations, such as genetic algorithms. Thus, the following is the policy API. Note the use of the policy supporter, which allows the querying of specific trials from the database. The policy supporter can also recover global states from study config metadata. OSS Vizier also has integrations with many of Google's other open source packages. Users can freely move to Vertex Vizier as it shares the same API with OSS Vizier. Furthermore, PyGlove may be used to easily write evolutionary algorithms. Additionally, users can hyperparameter tune their experiments with DeepMind's XManager. In conclusion, OSS Vizier is a fault-tolerant and flexible black box optimization service built upon universally used frameworks such as gRPC and protocol buffers. OSS Vizier supports multiple clients and diverse use cases and integrates well with other Google libraries. In the future, we also will support an extensive benchmarking system for researchers, as well as integrations with externally sourced packages. Below are the links to the open review and code repository. Thank you.